Chapter. We think we've got another great presentation as part of our series, MG Talks. My name is Tom Balf, and I'm the Executive Director here, and so I see some new faces, and so it's great to have you here this evening. A couple of logistical details. Bathrooms are down the stairs where you came in and sort of across the hall. Men's and ladies' room, and the exits are where you came in. And there's also exit past 10 over here and down the back stairways. I want to thank there's a number of contractors that are involved in tonight's presentation. We put a lot of time and effort and resources into it. I've only asked, since I knew that a lot of them were helping out, I did ask one of their subcontractors, Black Dog Divers, to be a sponsor of this evening. Black Dog has been involved with Maritime Gloucester for a long time in sort of support of the dive shop down here in Paul Harling. And they've been sort of a steady presence over the years and have supported us, and they're obviously doing commercial work on the site. But I want to thank them for their support over the years and for this evening in particular. I also want to talk about a couple of upcoming programs before I turn it over. One is our Sustainable Seafoods Dinner, which is next Wednesday evening at Latitude 43. This is our third annual dinner as a way to promote purchasing local seafood, as a way to support underutilized species, and as a way to really promote a harbor and a fishing town. So if you're interested, call Latitude 43, 978-281-0223 and reserve your spot. The chef will be talking that evening about the preparation of some of these seafoods, and I'll be sharing a few words about sort of the importance of supporting sustainable seafood preparation and meals. Beginning next week, next Thursday night, and throughout the month of April, we're supporting speakers from UMass Boston and their School for the Environment. Molly Letkavich, who many of you know, is a leading large pelagics researcher who used to be associated with the Marine Station over in Lanes Cove area, is now associated with UMass Boston, and a number of her colleagues will be talking about relevant ocean topics. I know the first speaker, Robin Hannigan, who's the dean of the school, will be talking about ocean acidification associated with climate change and the impacts of that on various species around here. I also want to thank Cape Ann TV for filming this evening, and that will be available in the near future, and we will announce that, and we'll also be streaming live on our YouTube channel this evening. Finally, before I turn it over, if you are not a member of Maritime Gloucester, as a way of supporting essentially these free presentations, we'd love to have your membership. We're just completing a March Madness, 30 new members in 30 days. We've got a couple members to go, and it's the last day. So please feel free to sign up tonight or put something in the donation box. With respect to this, the cleanup, before I hand it over, I do want to say that it's been a challenging number of years since I came on board 3.5 years ago, and for many of the folks up here, this has been a project that's 10 years in the making. I'd like to say that from Maritime Gloucester's perspective, it's been difficult, and it's a difficult time that we face going forward. We have had disagreements with National Grid as it relates to technical, financial, logistical issues. But I really want to say that National Grid, Ken Lento in particular, and their whole team, I can't say enough nice things about their professionalism, their competence, their communication, and their transparency regarding this project. It is a difficult project for Maritime Gloucester and for all of us, the city certainly included, the Coast Guard, but it has been a very collaborative project, and I think all of us that have been working on it are proud of that work effort. So without further ado, I'm going to turn it over to Ken Lento, the project manager from National Grid, to talk about this project.
Thanks, Tim. Good evening. Thank you for coming, showing interest in the project. National Grid this project is very important to us, and I'm hoping that the final product will actually be reciprocated by the city itself. So introductions, my name is Ken Lento. I am a project manager working for National Grid. I have been working on the project since it first started in 2005. I was originally the consultant on the project and then transferred into being the project manager for National Grid in 2009. I have a project team here on the premises. We consist of multiple consultants and contractors that have worked on this project over the years. I'll say them in alphabetical order. Anchor QEA is the marine side consultant. And then we have Charter Contracting, who is the contractor actually performing the remediation, and GZA Geo Environmental, who's doing the upland consulting work, and then also is the licensed site professional for this particular site. So what we're going to be talking about is a brief overview of what we're doing here. First, a little history, and then we're going to get right into some of the major elements that we did this particular season, and then do a brief overview of the second season of work. This is a two-season project. Seasons being, we started in September of 2015, and is going to end here in May, and then pick back up again in July, and hopefully be done in May of 2017. So we are going to be I'm going to be talking about 45 minutes or so. We do have a lot of time for questions after that, so I hope that everybody can hold their questions until the end. We'll have a very long session in case there is additional questions that everyone wants to answer. So, having said that, so where we're at along the harbor. So the site borders the harbor along 4 properties here, primarily. So we have, in the building we're at, Maritime Gloucester, right here. We have National Grid owned property, which is actually where the harbor master is located. Solomon Jacobs Park, and then the Coast Guard. So historically, the waterfront was much crowded. It actually is an industrial pass in this area. So we had marine railways on either side. Of course, the existing railway here at Maritime Gloucester is still here. And then the MGP, a manufactured gas plant that produced gas for the city from 1850s or so to about 1950s, was located currently what's the Solomon Jacobs Park and on the National Grid property. This is a legacy company of National Grid. It became, through various mergers over the years, became part of our responsibility. So this is a 1917 map of the area of Gloucester where we're at. Very industrial pass. We're looking at the railways, as I said, here, the gas plant here, and then the surrounding area was also a lot of fish processing, other maritime industry, sail manufacturing, paint manufacturing, things of that nature that actually would work for the maritime industry. So what it looked like, just to give you a little scope, this is of the Solomon Jacobs Park before we actually started work, looking down the driveway towards the harbor, and what it actually looked like at the plant in 1935. A similar view going back towards the land, showing the facility again. So we've been actually working out here for a long period of time, as Tom indicated, about 11 years. Originally we're doing the investigation phase. We spent a long time. It was a very extensive investigation. And during that investigation we did hundreds of actually locations, both sampling locations, both in the upland and in the water. Hundreds of actual samples were collected and analyzed to come up with this plan that we're actually implementing right now. That plan consisted of removing of soil behind the existing seawalls on the park and on National Grid's property, removing soil from out of the park and then putting in a multi-layer cap. We have coal tar being a byproduct of the actual manufacturing process. Basically when the coal was actually superheated to drive off the gas, the residuals was, one of the byproducts is actually coal tar. Coal tar was actually product that was tried to be sold. They used it in like roofing and asphalt, roadways, also used as in certain commercial products. Up until recently, it was actually a component of like Denorex used for treatment of psoriasis. But we have coal tar at depth here, about 60 feet down or so, where the interface of the till and the bedrock is located. So we're going to be putting in monitoring wells, recovery wells as part of this remediation, and that product will be removed and over the next few years after we actually get this system in place. And of course, we are removing sediments that have been impacted by the coal tar. Approximately 7 acres is within the dredge area. And then after we're finishing dredging, we're going to be putting in a sub-acreage cap over the sediments to make sure that there's no further migration of compounds into the waterway. So once we get all the plan all together, we come up with an engineering approach. We actually go through the permitting process, and this is one of our permitting plans with all the various features here. The one thing I wanted to point out here is these individual rectangle and trapezoidal cells. Each one of these is actually what's called a dredge management unit. So basically, we cut up the 7 acres into various manageable units that indicate what level of material needs to come out. So the two primary things I want to talk about tonight is the offshore dredging, which was actually completed this year, primarily completed, which is the offshore being anything past the harbor line into the navigational channel. So dredging, I'm sure you'll see it. I think it's actually still out in the harbor. So this is the dredging equipment that was used. The dredging work was actually performed from a subcontractor to Charter, Riverside and Pickering, out of New Hampshire. And so the various components that make up this platform. So we have the dredge plant. Basically, it's a barge with a control house, an excavator, in this case, it could be used as a crane. And then we have a resuspension control system here. This is basically a turbidity curtain that surrounds the area where the dredging is occurring to keep any sediment that is suspended into the water controlled into that one little area. And then the scow, where the sediment is deposited for then transport off-site, and our water treatment system. So I'll talk about each individual piece, just so. So the turbidity control system. So this is a rigid frame. Excuse me. So it's a turbidity curtain around the edges. It actually goes all the way down to the bottom, or just slightly off the bottom. You don't want to actually touch on the bottom because it actually disturbs the sediment even more. So it's a little bit raised off the bottom. And then we have a 9-foot tidal swing here in the harbor. So as the tide comes in and out, this is actually raised and lowered by these reefing lines so that it always is in so many feet off the bottom to make sure we control the turbidity that is occurring during the dredging operation. And of course, with the tidal swing back and forth, there's a lot of velocity, tidal currents. So it actually is anchored to make sure it doesn't get blown into where the dredge bucket is actually going down through the water column. So this was actually manufactured on site. It was put together here, specifically designed for this project. This is a view of it before it was actually deployed. And then it being deployed into the water. So there's a walkway here to allow the laborers to come around and move along and move those winching reefing lines as necessary. So the dredge plant. So the dredge plant is a large excavator. We're looking at about, I think, 28 feet of water depth here. So this boom is actually capable of reaching to 35 feet with the bucket on it. We have a 1 to 3 foot dredge cut in the harbor. We're moving about 1 to 3 feet in each one of those units of sediment that was being removed. So this was actually capable of making sure that we reached all of our dredge depths. And this is the control house, as I indicated. Inside is a unit that basically controls the operation of the barge itself. And then the barge itself is anchored with spuds. These things, metal tubes, are actually lowered into the sediment to hold the plant in place so that we can focus on one specific area at a time. And this back spud is actually a walking spud. So this is actually capable of actually moving slightly side to side, so that if we have to make adjustments, they can do so without actually moving the whole system. So this is a shot of actually the dredge in place, everything in place. So this bucket is an environmental bucket, and I'll get to it in a second. It's a little bit different than your standard mechanical dredging operation. So we have a sensor actually on the bucket, and this cord is actually going back into the cab of the operator. So they have controls in the cab to allow them to position the bucket wherever they need to. So the environmental bucket is a specially designed bucket for environmental work. It's designed to make sure that the sediment is kept within the bucket. It does allow some of the water that actually is generated when we actually take a scoop to come out, which is why we have this splash pad here. So the splash pad is, as the bucket is coming out of the water and moved over into the scow to dump this load, there is some little spillage of water. So the water is then sent back into the dredge area or into the scow. So this is an output on the screen that the operator is actually seeing in real time. As you see here, it can actually tell you exactly what depth he's at, and then the output that you actually see on the screen, so you can see exactly what he's doing. So again, a picture of the entire system. I don't know if you've seen the plants still out here, but this whole system is about the size of roughly the size of a football field. So this is about 250-foot long scow, and with the dredge plant here, the scow, and the water treatment on the other side, it's about 150 feet wide. The scow itself is can hold about 2,200 to 2,500 cubic yards of material, which is about a week worth of production that we were doing. So every week we would actually shift, well, approximately every week, we would load up a scow and have another one come in. Once the material is placed in the scow, we then pump off the water into our treatment system. So this treatment system was actually created for specifically this project. It actually was put together off-site and then floated here. But it's actually a modular system. So these floats are actually called flexi floats. It's almost like a Lego system. They snap them together so that you can make these as big as you need to in order to accommodate the size of the treatment system that you actually want to put on it. And the treatment system itself is multi-components. So we have product recovery. So if we generate any product during the operation, it then gets collected. It then goes through a various treatment, including removal of solids, and then a filtration step. It then goes through carbon for absorption of any organic compounds in the water, and then it also goes through a metal treatment step before eventually being discharged back into the harbor. So this is a picture of inside one of the trailer units that's on the floats. These are what are called bag filters. They're actually our particulate removal system. And then these are canisters holding the carbon and the metal treatment. So during the operation, we're also required to monitor the water to make sure that we're doing things in accordance with our permits, and also to make sure that we're not causing additional problems. So we use water monitoring equipment. There's measuring primarily turbidity, which we did not have any exceedances of our permit during the operation on the offshore dredging. So once the sediment gets to full, the material is actually, we pump off the remaining water. As you can see in here, it's got a little bit of debris, primarily fishing line, cable, lobster traps, things of that nature that was settled to the bottom over the years. And then the sediment is actually sent to New Jersey for further processing. So it's a good place for it, right? So it went to New Jersey for a specific reason. It actually is an alternative approach that the contractor came up with during the bidding process, and is one of the reasons why Charter, not to mention they're a great contractor, but it was one of the alternatives that they approached that actually won them the job. So originally we were supposed to send the material to our substation, which is on 109 Rogers Street, with very limited space there, which also limited the amount of production that we were actually looking to do. So by doing this alternative, we were able to speed up the process. It was a little bit more costly to send it there to New Jersey, but overall it was more cost effective, and also it lessened the impacts to the community. If we were looking at putting the material for processing through the substation, we were looking at more than 1,000 more trucks that were going through the city streets. So this, by sending it to New Jersey, you actually eliminated quite a bit of traffic during the project. So once it goes to New Jersey, the sediment actually is processed. We remove the water. It then gets sent to a thermal treatment facility where the organics are removed by heat, basically burnt off. And then finally it goes to another landfill in Pennsylvania to be used as daily cover. Daily cover. Every day they cover the trash in the landfill. So, so the question then is, how do you know you got everything, right? So on a regular basis, we're doing our survey of the bottom. We actually have a survey boat on site. It's a hydrographic survey. Basically, we have a sensor on the bottom. This is taking a picture of the bottom. That tells you if we met our design depths and make sure that we removed everything that needed to be done. And then also we do confirmatory sampling. Basically, these are sediment cores. Basically, we take a tube, we drive it into the sediment after we're done, and this is the final product. Nice clean sediment. We also send some samples off to a laboratory to confirm that we've removed everything we needed to remove. So all told, we've removed over 16,000 cubic yards this past season. We've finished the offshore dredging portion of this project. With the minor, using the survey, we identified a couple of isolated high spots that still need to be removed, but we were past our window of opportunity to do that work per our permits. We have a restriction not to do any silt producing work after February 15th. Based on those permits, after we did the survey, we realized we had a couple of high spots, so those will be addressed next season. So that's the offshore dredging. I'll talk a little bit about the park seawall work. So this is the Solomon Jacobs Park wall. As I said, this is a historical seawall. It actually dates back to the plant itself. This is actually circa, I think, 1890 or so. So it's greater than 100 years old, was ending its useful life. As you can see here, there's a slight bow in the wall. This is actually a failure. It's actually, the soil is starting to move, and these stones are actually moved sliding out to the harbor. So, and on the national grid side, it was even a little bit more pronounced. We actually had some sediment issues in the platform. If anyone walked out here, you probably saw some patches over here. It's actually soil being lost through the seawall. But this seawall is historic in nature. It actually required additional permits to make sure that we're putting this back in. We are actually working with the marine archaeologists and other professionals to make sure that we're putting back the new seawall in similar aesthetics as the original intent, the original wall. So at the end of the day, you'll hopefully we'll have an improved seawall that will last hopefully another 100 years. And also with the improvements of the seawall itself, we are removing, or have removed, National Grid's pier, which is actually was in a state of disrepair itself and needed to be replaced. The city is actually going to be taking over our property as a lease and installing a new floating dock system. So hopefully we'll have a very improved, more functioning waterfront when we're done. So how do we do this, right? So we need to remove this soil. It's about 2,000 cubic yards of soil behind the wall. It's not like we can just go in and remove it because you have all the soil behind it. We have buildings behind it. We've got the Coast Guard operations over here. So the first step is actually making sure that this material stays in place. So we're going to be doing that, or we did do that, with a supportive excavation wall. But the first step is to remove the dock. Then we can come in and install the excavation. While the old seawall is still in place, we install this other wall, temporary, behind it. And then we can remove the soil and then the seawalls before we rebuild. Before we do any work, we make sure that we have the proper controls in place. So one of the first things we make sure that we do is we're monitoring various things. One being air monitoring. So we have air monitoring stations, and if you've been around the maritime Gloucester property, there's actually one right beneath us, I believe over in this corner. And we have a couple out near the park, and then one on the Coast Guard. So these are monitoring the air 24/7, 7 days a week, 365 days a year. They're online at all time. They consist of multiple detectors. They are used to test for dust, and then also for organics in the air. So this is actually fed back to a computer on the site, and then if we're off-site at the time, we are actually linked in through mobile phone to get, if there's any kind of alerts from the system, that the off-site project people can actually get the alert and then relay to the people back at the site, or come to the site to make sure to see what's going on. We are also monitoring stability. So we're making sure that the actual infrastructure that stays in place, this is the U.S. Coast Guard seawall, doesn't move during our work. So these are actually sensors that, again, are fed back to a computer, and these monitor if there's any minute movement in the seawall itself. So we know well before if there's an issue of this thing having some kind of stability problem. And of course, during the work, we want to make sure that we contain any suspended solids. So we actually have another turbidity curtain around the work area. It's a very similar situation as with the marine dredging, and very similar concept, except that it's a long linear length of boom that surrounds the entire work area instead of a very isolated area. So the first step, as I said, was the removal of the timber pier. Barge-mounted crane, actually we're able to cut the pier up into sections and place it into a container for delivery to another location off-site. Now we have very limited space here at the site. You see it's a very congested site itself, a lot of equipment, and so we couldn't able to move this material onto this land and ship it off this way. So this material was actually shipped to Quincy to a contractor yard, where it was then picked up out of the water and then put onto trucks, and then it was shipped off to another landfill. So, but this shows a shot in mid-November. We actually started the work after Labor Day, with the agreement with the city, to make sure that we didn't impact the tourism season. So we got access in September, and this is the progress that we've made through November. As you can see, we have a turbidity curtain, multiple curtains out around the work area, and that the pier has already been removed. We had also started to remove some of the surface soils in the park. So this is the excavation support system. It's a multi-component system designed to hold the soil in the park back. The first step is actually the installation of 42 concrete-filled steel pipes. The pipes themselves are about 12 inches in diameter. Is then a steel member is actually attached to the mini piles, these steel piles. It's called a wale. And then the wale is used to connect these concrete blocks to the wale is then connected to the concrete blocks using these tie rods. So the first step is actually getting our equipment down to the proper elevation. So this is the removal of the surface soils, so we can get our drill rig in to drill the piles. This is actually a layout of where the actual piles will go. You can see the spacing here, very tight spacing. And then the actual drill rig itself, putting the piles in. The elevation that we're at is actually, the park elevation was roughly around 10. So we removed a few feet of soil in order to get the drill rig in here. And you can see we've already made some advancement here with the roll piles in place, working on the progress. And then this is the row in place as we start to remove some of the soil in front of it. So obviously we're working with the tides. We know that there was difficult subsurface conditions here. Through all our investigative work, we've actually encountered sizable boulders. I believe the largest that we encountered was about 14 feet in diameter. To give you an idea, it's somewhere very close to this from the floor, almost up to the ceiling in size. So it's large boulders underneath us. So we didn't encounter the 14-footers, but we did encounter a few sizable pieces that had to be broken up. So we know that we had a lot of work to do within the time allotted to us. Obviously, we had to stop. We had to get the foundation of the new wall in place prior to February 15th, the same window of opportunity that we had with the dredging. So we were working around the tides. We actually ended up working night shifts, double shifts, in order to make sure that we got done in accordance with the schedule. So as I said, here we are busting up some of the rocks that we encountered. The rocks were too big to actually send to a disposal facility as is. So they had to be sized appropriately to actually get into a truck and shipped off to the landfill where this material was going. So as part of that, we make sure we control our dust being generated as we bust this up. This is a hydraulic hammer, breaking up rocks into about 6-inch or smaller sized pieces. And we use water to suppress the dust during the work. And then obviously the coal tar impacted soil has an odor to it. This is odor-suppressant foam, which we try to do to knock down the odor. This odor-suppressant foam is used during the work so that as we generate more and more soil, it goes into the stockpile area and then covered with foam. The foam acts as almost like a barrier over the soil to keep any odors in place. And then at the end of the day, we actually use tarps to further control the odors when we leave for the site. So this is a picture of the mini piles, the steel piles in place. What is being welded is the bracket onto the piles, and the bracket will be used to hold the whale. As I said, we were working at various times to work around the tides. As you saw before in an earlier picture, you saw that this area is actually in the intertidal zone right now. So we're working at night around the tide to make sure that we can get this steel member in. So this is the concrete blocks that were put back into the park. These basically are the anchors for the system. They're also called dead men. And then we use the tie rod to connect the mini piles whale system to the dead men. And then we use structural fill to backfill the area for additional support. So you can see the spacing between the piles. So one of the ways we control the soil from emanating from the land into the water through the piles is we put in lagging. So this is a sequentially done. So we put down a few boards, we excavate, put down a few more boards, excavate, and so on and so forth, until we're about 12 feet below the the original ground surface of the park. So this is just showing the excavation. Obviously, it's a iterative approach, as I indicated, where we're excavating and then putting lagging on. So this is, again, on the outbound tide, removing the soil in front of the supportive excavation wall. And we're also removing the stones and the soil at the same time. And this is how it looks with all the lagging in place. And then once we get down to a point in time when we can't put the lagging in from the surface, we went to a steel plate as a means of holding back the soil instead of the wood lagging. And the the steel plates were put into place through guides, and then they were put into place, and as we advanced the excavation, the plates would then push down farther, and then excavate a little more, push down a little farther. So obviously, when we're doing this, we encountered more rocks, and so in order to get that, we were using barge-mounted equipment to hammer out those rocks as we encountered them, so we can advance the steel plates. And when we're all done and we're at the right elevation, we use divers to cut the plates into place. Divers were Black Dog Divers. They were a subcontractor to Charter, and they're the ones that are sponsoring this particular presentation. So what we did was a backwards, inward-out approach. So we would come down a ramp and start really on the U.S. Coast Guard side, and then work our way out. So that way we would actually be continuously removing the soil up and out, and we wouldn't have to traverse the area where we excavated first. So this is a picture of what it would actually look like at high tide. As you can see, the water actually is past the point of the actual supportive excavation. And these are our sandbags that we're going to be placing in a minute here to form up the new wall foundation. But before we actually start putting the new wall back in, we have to make sure that we actually have removed everything that needed to be done. So we are surveying on a daily basis. Not only are we surveying the work area that we're doing to make sure that we've gotten all the soil out, but we're also monitoring, very similar to the sensors we have on the Coast Guard wall and the Maritime Gloucester walls, is we're also surveying these points to make sure that this supportive excavation wall isn't moving during our work as well. Again, the survey work, surveying the area in question. And then during this process, we're removing the granite block, all right? So the granite block is actually being reused to the extent we can. We want to make sure that we have the same aesthetics that we had from the original wall. So we're taking care to remove them very slowly, carefully, so we don't mar the stones and we have chips or damage to it. So when you actually get the new seawall put into place, it looks very similar to what was there before and also not damaged. So as we're excavating, the blocks are actually steam cleaned and actually sorted to size so that we can, when we put the wall back together, we know how they can actually go back together in the right form. So obviously some of these stones were actually impacted with coal tar and we couldn't use some of them. We actually had to bust them up and then dispose of them. So this is actually the base of the old wall. Obviously it's a pile of stone. More than likely it was a natural formation that they supplemented at the time, putting in additional boulders to form the base of the old seawall at the time. Obviously there's a lot of stone here that had to be removed and picked up. It's actually one of the things that caused us the most delays is actually dealing with the stone, taking it out of the excavation and then busting it all up. The stones that we encountered were actually quite large. Not as big as the 14-foot diameter ones, but this is actually the size of a small car. A couple of boulders. So all this, as it went into the stockpile area, was then broken up after the fact in the stockpile area and then shipped off site. So after we remove all the soil, we started rebuilding the seawall. And with any concrete work that we normally do, you have to build a form. Obviously, we're not going to be able to do a wood form. So we used sandbags. These sandbags are about 3.5 foot by 3.5 foot with multiple layers. And they formed the barrier around the concrete that was going to be used as the base. So the top of this, the top of the concrete base for the new seawall is about 15 feet below the former surface of the park. And then the bottom of the concrete base is about 22 feet below the top of the park. So we had to go quite deep. So most of that work is actually done by various equipment, by both land and water. This is a sandbag being moved from the land into place, but we also use barge-mounted equipment when necessary. And then we also had a divers assisting us to place them in the proper location. And of course, we're working around tides and whatnot, so we're actually, again, continuing to work at night. So we're putting in once we get the sandbags in place that actually form the concrete was coming in. Obviously, we can't dump a concrete truck right over the side. So the concrete was actually pumped into place with this pump truck. So the concrete trucks would come in, empty into a hopper, and then the concrete was pumped over the excavation into the water column and placed when there's enough water in place to have a diver in the water to assist us putting the concrete in. And then once the concrete is pumped in, we actually survey it to make sure it actually at the right elevation. So, and then while we're doing this work, they were moving the stones over to our substation where it was actually temporarily stored. And someone, I don't know who actually with the project team, came up with the idea of laying out the stones for the wall to save some time in the substation so that they would have the right orientation when we actually go back to put it back into the water to save some time. So what you see here is also holes in the stones that were placed in there. These are actually the holes where we're going to put dowels into that would anchor it to the concrete base. So this is actually the first course of wall and the second course that actually have been installed, laid out on the substation. It was then shipped back to the site and offloaded. So these are what called Lewis pins. Again, it's a means of picking up the stone without marring the stone to the extent we could. And then they're slowly placed into the water. So this is the stone going back in front of the sandbags. So this is actually showing 2 rows of stone. We have actually got to the point now we have 3 layers in on the front face. But this is, we didn't have pictures of that just yet. It was as we were working, pulling this together. So this is what it would look like. And as it slowly comes up, and that's the seawall work. So a brief into the second season of work. So as I said, this is a 2-season project. We're nearing completion here. The idea is that we get the seawall done by middle of May, so that the park can then be put back into service during the summer months. And then we then have permission to go back into the city to continue our work into the park by the city after Labor Day again. But the second season of work consists of the dredging in the nearshore area, which is anything within the harbor line, and also getting the isolated high spots that I mentioned on the offshore, and putting in a new seawall in front of the National Grid building. So this seawall was actually a feature that should have been put in season 1. However, the approach that we were using for the foundation for this wall, we started doing it, and we encountered very difficult subsurface conditions in this one particular area, and we actually couldn't physically implement the approach that we indicated. So this is actually moved to second season. We're coming up with a different approach to install that foundation, and that will then be sent to the regulators to get the proper permission and to get amendments to our permits in order to install this. And then we have, once we get all the material out, we're putting in what they call a pour water cap here along the shoreline, basically to prevent any further migration of any contaminants through the water column, through the sediments into the water column. And then finally, restoration. So this work will start in July on the Coast Guard property. And then in August, we're shifting over to Maritime Gloucester. And then the whole area will then be under construction in September. And we're hoping that we can get everything done by May of 2017. So we have a website for this project. It's actually, that's the address. We also have fact sheets. We have fact sheets on a continuous basis at the, on the fence outside of our construction site. I think we might actually have a few here as well, if anybody would like them. But obviously, I'm available. My information is actually on the website. I am available by email. We provide periodic updates on the website. I know a few of the people that were in attendance actually were on the notification list. We try to provide notification to those attendees or those requesters on a couple of month basis. I know that sometimes there's been a delay here and there, but we do try to keep everybody informed and on as much as we can. So, now, questions? Yes.
What's the impact of coal tar on the marine environment aside from psoriasis control?
So if I hear that correctly, is like, what is the impact of coal tar on the marine environment?
If you didn't clean it up, what would be the negative impact?
Well, it is a negative impact is that it would be, well, still present, and if you disturb it, it does have the ability to get into the water column, and then obviously there is a potential risk posed by that to the benthic organisms and whatnot that use that sediment.
So is it toxic if it's ingested?
So yes, just like anything, pretty much anything is toxic at certain levels that is ingested. But yes, I mean, coal tar is not something that you want to eat. Although there was no current exposure, no risk posed by this site, there is a potential in the future if one disturbs it, contacts it, gets an incidental ingestion, gets it on their skin with certain levels of contamination. So yes, there was a potential for the future risk, but there was no health risk as it was currently.
As a follow-up to that question, you had said that during the dredging you found lobster pots in the dredging, and I was wondering if those 7 acres was used for lobstering.
Not to my knowledge. My understanding is that the inner harbor here is actually restricted from lobstering. It actually is the line of demarcation, I believe, is farther out in the harbor where there is some pots. So there was no actual pots placement within the dredge area. Sure.
Yeah, I'm assuming you determined an area that you're going to be investigating based on the samples that you took and depths that you have to do your digging in. There's a lot of water moving in and out of that site with tide cycles and equipment moving up and down, and I'm wondering to what extent you're going to look at this after you're done and see whether or not any of this stuff is sort of spread around the harbor more, just due to the day-to-day activities and the sediments that are going to escape those barriers.
Okay, so as I understand the question is how do you monitor it after the fact to make sure that there is no further spread of contamination? So what we try to do is actually do that in real time. So as I indicated before, once we're done with the dredging, we actually went in and actually took additional cores after we're done, so that we showed through those cores that there wasn't any continuing spread of contamination.
So you did sampling outside your screens, outside
Well,
your barriers to make sure nothing's moved off.
Well, I wouldn't, so we do monitoring, water column monitoring outside the barriers. But the actual footprint of the actual dredge area is where we actually took the samples, within that dredged area. Prior to that, we identified the area that needed to be cleaned up, that the outside those areas didn't have the levels of impacts. We do not expect, because of the way that we actually do the work, that the spread of contamination would actually go farther than what we removed.
Are you going to look to determine that?
Well, no. To answer your question, no, because I think that we've done enough work to actually answer that question so that we know that that's not going to occur.
Okay, the only reason I ask is I know that when they were excavating PCBs in the Housatonic River, one of the biggest concerns was the operations actually causing, sediment laden PCBs to move downstream in a lot of different spots. And a lot of people tried very hard to not let that happen, but it still happens.
Yeah, I don't know how to answer that question. So it's a different situation, it's a different site. We have controls in place to make sure that that doesn't happen here. And I think that the way we actually did the work has demonstrated that that is not the case.
What kind of public access is there going to be on Jacobs Park? And is there going to be a place for the water launch and the public launch to operate?
Yes, so I assume, so let me answer the question. So the question is what is the access going to be for the park in the future? I'm hoping that you mean during final condition, right? So I'll do the temporary first. So during June, July, August of this year, there'll be limited use. It will be restored so that people can use it, but it won't have the full system in place during this time. It's only going to be one run of docks, so the harbor master will be able to use it, and then whatever was used before for transient boaters to come in with dinghies. And then also, I believe that there was a shuttle service working out of there as well. That will still be able to occur. In the future, when we're done, the system is such that it's going to have multiple floating docks, and it's a better configuration for the future use. The harbor master and the city is actually installing the floating dock system under various other contracts. Under our work, we actually are starting to put in the piles for the final. You'll see a row of piles out there. We didn't quite finish that, but that will be the new floating dock system, those piles. And it will be used for both the harbor master's operations on one side, and then public landings will still be in operation on the other side. So it will be an improved use prior to what was there before. I think it was very limited in the past. Yes?
I'm not being accusatory, but I was wondering if the dredging, if that will affect the transient mooring field and the resident mooring field.
No,
Right here, right off the.
so the mooring field, my understanding to that is actually it's outside of our dredge area. It actually was not part of the area in question, and should not have been impacted by our work. I understand that they're actually going to be starting to put the moorings in place very soon here as part of the normal operation.
I have a couple of questions. So the 6-acre field that you've dredged, are you putting a cap over that whole?
No.
Oh.
So the answer is, so we're not putting a cap over the entire area. It actually, once we're done with the dredging, it actually is shown that we don't need to put any material back in, and per our permits, that was what was approved. So there will be no additional material going back into the channel. The only area that will be capped will actually be a very limited area. I'm not sure what the actual square footage is, but it's a very isolated area next to the shoreline of Solomon Jacobs Park and the Coast Guard property.
So you started to answer one of my next questions. Was that, so you don't have to put any material back where you dredge it through natural time and tide, it's just going to kind of fill in?
So yes, that is correct.
New sediment and new, oh, okay.
Yeah, so my understanding is that it made no sense to actually put material back into a navigational channel that may be actually dredged in the future to accommodate deeper draft vessels.
And the base of the seawall, you said the top of it is at 15 feet below the surface?
Excuse me, the foundation.
Foundation.
The foundation's about 12 feet. The top of the foundation for the wall
Yeah.
is about 12 feet below the surface of the park.
And then you said it went all the way down to 22 feet, or?
About 22 feet. So the foundation itself is about, did I get those numbers wrong?
It's 15 feet down from the surface, 15 to 22.
So it's seven.
I'm corrected.
It's
So
seven.
it's a six or so foot thick concrete foundation.
It's 7 feet thick.
Six
Wow.
and some.
It is a very robust system.
Yeah.
We're hoping that I always joke at it, but I'm making sure that this doesn't fall down in my lifetime.
Can you discuss the plan to remove the non-aqueous phase liquids that are legacy from the coal tar?
you repeat that?
Sure. I understand from the GCA report that there are some non-aqueous phase liquids
Yes.
that are down, that are below grade, and that there's a plan, because those represent a continuing source of contamination, that there's a plan to remove those. And I understand anecdotally that when some of the piles were driven, at least on one occasion, that you actually had creosote oil come to the surface that had to be recaptured and dealt with. You talk about the plan to treat the non-aqueous phase, essentially free product that you have down there, and how you're going to handle it.
Of course. So as part of the system, we're actually putting in recovery wells along the backside of the seawall. We are putting in an automated system to recover that product that's located at depth. Right? That will be pumped into a treatment system that's actually within the building, the National Grid zone, and that'll be operated continuously until we actually reduce the levels in those wells to acceptable criteria. That will, I think it will be start operation once we get the system in place, probably in April of 2017. So we also have deed restrictions in place, and we have agreements in place with the various property owners that if they are going to do improvements to their site after we're gone, that we have controls in place to make sure that if they do go down to those depths where that product is located, that we have the proper environmental controls in place to handle that during that work.
So is the plan to leave some of that separate phase material in place, or is that going to be scavenged over time, and what's the timeline to recover that?
So we're going to be removing what we can from the upland. We anticipate that that's going to operate that system more than 5 years, hopefully less than 15, so our rough guess. And we'll remove that material until we can. Whatever can be recovered, we will recover. Did I answer the question?
Sure.
Okay.
You said you're going to, you hope that the new restored seawall will last 100 years. Are you restoring to the original height, or are you allowing for sea level rise?
So that's a good question. So we did not increase the level of the height of the wall. So we did not raise the park elevation. And that's specifically for a purpose, is to make sure that we don't, we're not surrounding our neighbors, they're not raising theirs. So if you put in an isolated location like that, obviously you're going to be flooding out everybody else. So we came back to the same height that was originally proposed, was originally there, but we did account for that a rise of several feet of new stone that could be added after the fact without any additional changes to the system. So one of the reasons why we have such a robust foundation is to accommodate the additional rise of the material to account for the climate change.
That non-aqueous solution that he was talking about?
Yes.
That's a byproduct of the coal tar process. Is that like creosote?
It's very similar to creosote.
And it was just allowed to seep down into the soil when they were manufacturing, or were the wells actually in the soil that captured it at the time?
No, I don't believe there was any wells here at the time. It was back in that time period, the environmental controls that were in place were not what they are now. Standard operating procedures were not as what they are during current industrial practices. So there were spills, releases over time. This plant is actually a little bit different than a lot of other ones. There's no railroad that comes directly to the plant. So a lot of the work, all the materials that were coming into and out of the site was through the water. And obviously what happened here, what we surmise happened is that there was spills and releases during that transfer from upland to the water, to barges and whatnot that occurred near the shore. And then that material then migrated out farther into the harbor. And then over a period of time, there was also dredging that occurred. And during that dredging, it kind of stirred things up and spread it around a little bit more.
First of all, I think you've done a nice job, thank you. Do you have a timetable as to when the maritime wharf and ancillary floats are going to be back in operation next year?
So right now, we're anticipating, we're starting August 1st. We have a lot of work to do in the next season. especially on the Maritime Gloucester property. And we are, so come August 1st, we're hoping to actually start work, immediately removing the wharf and other ancillary floats and whatnot. We will then start our dredging. We are actually hoping that we get starting rebuilding sometime in the, I think it's based on our current schedule, in the March timeframe. March timeframe, where we start rebuilding everything.
And what is your expected completion date?
Well, we are expected to be done with everything in May of 2017. I can't remember the actual date that we have on our,
So will the ancillary floats be available for use prior to your completion date?
as right now, I can't say for sure. It would depend on how construction goes and how quickly it can be done. But if you give me your name, I could probably give you better information if I could take a look at our construction schedule. I actually don't know the information off the top of my head.
So I think, I mean, it's May 1st, 2017. I think there's some language in our agreement that sort of allows for stuff, because the Ardell would like to be there before the Gigs would like to be there that last week. But it's going to be right up against May 1st. And just to clarify what Ken said is that the piles will have to be put in place, during this season before February 15th.
Right.
Even though the actual work above water will not commence until March.
Are you at liberty to tell us what this puppy costs?
I think it's actually a published number.
Which
It was
is,
actually in the paper.
which would be?
$30 million.
Thank you.
How many government agencies were involved in all these permits that you had to get?
A lot. All of them. You want me to list them? I can, but it's a long list. So we actually have local Conservation Commission wetland requirements. We also have state level permits in multiple departments. Coastal Zone Management, Department of Environmental Protection, multiple actual departments within, excuse me, offices within the Department of Environmental Protection. We have federal under Army Corps of Engineers and various other agencies under that, including NOAA. And
What was the NOAA permit?
that was under the Army Corps. 404.
I understand that, but that's Army Corps permit.
I believe that NOAA was consulting on that, if I'm not mistaken. And then we also had another Army Corps, because we're working in the navigational channel, which is a section 408 permit. So all various stages of government were involved, and we had to get approval from.
So I want to go back to this, this remaining creosote-like fluid. Where is it right now? Is it down, did it seep down into bedrock and create little in voids and pools of it, and it has to be collected in wells, or?
Yes, so coal tar in itself is what they call a dense, non-aqueous phase liquid. Basically, its specific gravity is actually heavier than water, or higher than water. So basically, it sinks through the water column.
Right.
So as it gets into the subsurface, it migrates downward until it actually hits a confining layer. In this particular case, we have a glacial till, deposited during the glaciers at a depth of, I want to 20-something feet to about, I want to say 60 feet. It varies over the site. The geology out here is such that bedrock actually has quite a bit of change in a matter of feet here. So the glacial till's on top of that, and then the coal tar is actually went through the column, sits on various pockets, and then also got into the bedrock. And we're seeing it in wells about as deep as 60 feet below the ground surface.
Wow. So are these wells actively pumping it up, or?
They will be installed as part of our work.
I'm sorry?
They are being installed as part of this work.
And they'll actually be pumping down at these depths to?
So we're going to be putting in recovery wells as part of this work in season 2. We did do some limited removal during earlier phases of the work. It was done to figure out what we actually needed to do as part of the system, what kind of production rates we were going to get. We actually had a trailer on the Coast Guard property. It was actually a one-unit a one well system where we've been pumping to come up with those design parameters. So it's, you may find one well that has product in it and 2 feet away it doesn't.
Right.
But we have an idea where it is, and the wells will be located based on that information that we do have.
And then that gets pumped up into a system you said that's on site here too.
Correct.
Wow.
And then that will be disposed of as we accumulate a drum's worth of product. The other feature of the seawall, and I didn't make mention of this, is that behind the seawall, to prevent any further contamination from migrating from the upland into the water column, is that this wall is actually designed to absorb contaminants as it comes through the soil into the harbor. So behind the granite seawall is actually going to be a layer of absorbent material that as the water comes through, it will, the absorbent material will remove any contaminants from that water as it discharges back into the ocean. And that will actually be installed during the season. And the design life of that will be anticipated to be more than 30 years. But if need be, that will be removed and replaced. We've designed the system to do that if necessary.
Just quickly, is that those concrete columns that you put in with the whale, that's staying in place? Is that correct?
So parts of that will be removed. I believe that, someone needs to probably give me a little help on this one, but I believe that the concrete will be left in place, but there's certain elements that are at a certain, higher than, I think, 5 feet below the surface, will be cut off and removed. Because we want to make sure that there's no impact of the wall on the park itself. And I believe we're actually removing the wood lagging as we come up as well. But the concrete will be left in place, and I believe that the piles will be left in place, but at a lower elevation.
What would be a threshold for determining over the years if the absorbent material that's underground, you said, may need to be removed? What actually is your threshold? Are you going to be testing those absorbent booms underground?
It's going to be based on visual observation.
But you can't see them.
No. The absorbent material itself will be, as sheens come through, if we see any presence of sheens being generated, obviously we know that the absorbent material would need to be replaced.
So the working assumption would be that they may actually be concentrated in doing their job, but they can just stay down there.
Correct.
Okay.
Do you have any sense of what the production from your recovery wells is likely to be in terms of gallons a minute per well or for the whole system?
I don't know the number off the top of my head. I can get you that information. I think with the last report that we produced for the state, I want to say that we recovered a couple of 100 gallons over a year or more.
I see.
So it's not a very fast recovery rate.
Yeah, Till would not be a good producer.
No. Yes.
Sorry, I've got more questions. Going way back to one of the earliest slides you showed that showed the boundary, and I noticed the eastern boundary was very sharply defined. I'm guessing it's a property boundary with the Marigold or whoever owns beyond that. Is that silt been tested as well? Are they going to be responsible for any removal on further property, or?
I'm not sure I know where you were talking about.
Over would be the eastern edge towards the inner harbor?
On the dredging?
Yeah.
So we've actually done sampling over in that area, and we've identified the limits, and it did not extend onto,
I think it's is that a Marigold, Tom?
no, it's actually, the next door neighbor to Maritime Gloucester. Stock fisheries, or the former stock fisheries. We actually the MGP impacts are actually a little bit before that. We're actually removing that material as per agreement with Maritime Gloucester for their purposes.
But were you required at all to test beyond?
We did,
Okay.
and the sampling indicated that we didn't have levels that needed to be removed over that area.
Okay.
Any of this work being done pursuant to the federal consent order and the Clean Water Act?
No.
How is the groundwater, putting aside for a minute the separate phase of Green Apple, the next 96 days, how is the groundwater being treated?
The groundwater is not being treated.
Is the groundwater is contaminated?
That is correct.
And so that continues to be allowed to flush out into the harbor?
That is correct. There are levels associated with that that didn't meet cleanup requirements, and met standards.
Even convention?
That's correct.
All right, well, Ken, and people in this room are now the most knowledgeable people on the face of Gloucester or Cape Ann on the harbor cleanup. Thanks again for coming this evening. I hope we'll join you. Hope you'll join us in April. And again, if you want to be a member, come see me. But thanks again. Have a nice night.